Hi, everyone. Welcome to today's webinar on building event-driven applications with serverless containers. My name is Vibhav, and I'm a senior product manager with AWS Containers, where I primarily focus on Amazon ECS. I've been with ECS for over 2 years, and I focus on a number of feature areas for ECS across the control plane, data plane, developer experience, and orchestration. Thank you for joining me today. Before we dive into things, I'll take a moment to briefly talk about our agenda for today. So I'll start by spending some time talking about event-driven services, what these are, and briefly discussing some use cases we have heard from customers about event-driven use cases and why it makes sense to use containers for these. After this, we will dive deep into how you can build event-driven services with serverless containers, and I'll also run a demo for building an event-driven service with ECS and Fargate. Finally, I will share some considerations and takeaways that I'd like all of you to leave with today and share a number of useful resources that you might want to look at after this presentation. All right, with that, I'll kick things started. So before we get started into actually building event-driven services with containers, let's briefly take a moment to discuss what are event-driven services and when and why you should use them. So let's start by talking about a few use cases I've heard from a variety of customers over the years. Data. Data is ubiquitous in the 21st century, and customers across industries want to harness this data to generate business insights. However, thanks to the garbage in, garbage out principle, it is essential to validate any data before using it for generating insights, running analysis, or whatnot. Hence, a common use case we hear from customers across industries is to run validation checks and pre-process data before it's used for downstream processing. This applies across the spectrum, whether you're running an ETL pipeline, using this data simply to generate a report for executive consumption, or running a machine learning workload. Across the board, running validation and pre-processing processes is pretty critical. Online transactions have become a part of our everyday life over the past decade, be it for e-commerce, for digital purchases of myriad kinds. But alongside this, there's also been a significant proliferation in online fraud. As a result, we're seeing numerous online sellers, in addition to payment processors, building systems which run checks to ensure that transactions are not fraudulent and are kosher. As with other industries, there's an increasing emphasis on using and analyzing data in the healthcare space as well. An interesting use case that we heard from one of our customers in the healthcare services was an application that takes millions of patient records as inputs and calculates performance metrics for over 100,000 care providers. So taking a step back, if we look across all of these use cases, a common thread emerges. In each of these examples, we see that there's something happening which triggers a notification, which is then consumed by a downstream service, whether that be a dataset becoming available, a transaction taking place, or new data coming in from a care provider. In each of these cases, there is a notification being generated, which is then consumed by the application to run some process. All of the use cases we just discussed can be called examples of event-driven applications. Such applications generally process work asynchronously in response to an event via a push or pull mechanism, usually pulled or pushed from an event source such as a queue or stream. Because of this asynchronous communication pattern, applications which use event-driven architectures enable better decoupling across components with fewer dependencies, making the application itself more extensible and more resilient. Now, let's talk about why you should consider using containers and specifically serverless containers for your event-driven applications. Before we even go to serverless containers and how you can build applications with serverless containers, let's pause for a moment and discuss why and when it makes sense to use containers for event-driven applications. Customers are increasingly standardizing on containers as their primary software delivery mechanism. By using containers for your event-driven apps in addition to request response apps, allows you to use your same CI/CD pipelines for all of your applications. This is probably the single biggest reason why we hear more customers using containers for their event-driven applications. Furthermore, by using containers, you retain control over how your application scales and responds to traffic spikes, as well as how much load it can handle. You can set both of these controls depending upon your application's tolerance to delays. In some cases, it might be okay to not scale the application too aggressively if there are no business critical dependencies, but in other cases, it might be critical to do so. For example, during a sale event, an e-commerce company which uses an event-driven architecture can potentially tolerate delays of minutes or even hours for running fraud detection checks. But the same company would likely want to ensure that inventory management, which might also be built in an event-driven manner, scales more aggressively to ensure that there isn't a backlog of events and to make sure that inventory is tracked at a much more rapid pace. Finally, by using long-running containers which continuously pull and process events, allows you to share the startup costs incurred, which can include database and network connections, data transfer costs, and other costs that might be incurred over hundreds or thousands of events that a single container might process. Depending upon your application's traffic pattern, this can be a significant saving. Now, before we dive into why you should specifically think about ECS and Fargate for event-driven applications, I do want to take a minute and give you a brief introduction to ECS and Fargate for those of you who might not be familiar with our container offerings at AWS. ECS, which is short for Elastic Container Service, is a fully managed container orchestration service which manages the end-to-end lifecycle of your containerized applications. ECS provides a battle-tested managed control plane which allows you to provision, manage, and scale your containerized workloads on AWS infrastructure with EC2 or Fargate, as well as your own compute with ECS Anywhere. ECS is deeply AWS native and is integrated with a wide range of AWS services such as IAM, Secrets Manager, EventBridge, tags, etc. As such, this makes it easy for you to use best practice tooling for your application without needing to worry about the underlying plumbing. Fargate is AWS's serverless compute engine for containers, which allows customers to run their containerized workloads without needing to provision, manage, batch, or update their EC2 capacity. Each container on Fargate runs in its own VM, enabling robust isolation by design, which provides a strong security posture. Furthermore, Fargate supports Spot and Graviton to help you optimize on your cost savings. So now that we spoke a little bit about ECS and Fargate, let's talk about why you should consider using ECS and Fargate for your event-driven applications. Probably the single biggest benefit of using ECS Fargate for running your event-driven workloads, or any workload for that matter, is the sheer simplicity it enables. ECS provides a fully managed control plane while Fargate abstracts the need to manage and scale your compute infrastructure. Bringing both together allows you to simply focus on building your application without needing to worry about managing and scaling for your hosts or managing and updating your control plane. Integration with Spot. Because event-driven workloads are generally asynchronous in nature, customers often find it beneficial to use a mix of Spot and on-demand capacity for these workloads. ECS enables you to use Spot for both Fargate as well as EC2. With ECS, you can easily configure how much Spot and on-demand capacity you want to use for your event-driven workload, depending again upon your application's tolerance. And depending upon your application, this can mean significant savings for you. We discussed briefly about the controlled scalability that containers provide. ECS gives you all of these controls for free without you needing to install or manage any plugins or controllers. ECS natively integrates with Amazon application autoscaling, which allows you to configure scaling policies for your event-driven ECS applications simply by pointing to the metric that you want to use for your application and the policy you want it to follow. Now, before we move further, I do want to address the elephant in the room. One of the most popular ways to build event-driven applications in AWS is using Lambda functions. Lambda provides a fully managed integration with a wide spectrum of event sources such as SQS, Kinesis, MSK, and many others, which makes it easy for you to build and deploy applications that respond to events with Lambda. However, sometimes applications can have specific infrastructure requirements or need to run for longer than 15 minutes. ECS, on the other hand, gives you the flexibility to use both serverless compute with Fargate or infrastructure of your choice with EC2. Moreover, for some applications which need to consistently process high volumes of events, customers can find it more efficient to deploy such applications as long-running ECS services, where each container continuously pulls and processes events instead of using Lambda. On the flip side, if your workload is spiky in nature, it might be more beneficial to use Lambda over Fargate because of its faster scaling pattern. As a general use of thumb, you should consider using ECS for your event-driven application if your application needs to consistently process a high volume of events or it needs specialized compute such as GPU to run on. For many other use cases, using Lambda would likely provide a better and simpler solution for your application. Since we're on the topic of Lambda, I do want to clarify that while Lambda supports container images as a packaging format, everything I said here about Lambda is also true for applications packaged as container images and deployed to Lambda. In general, whenever I talk about containers in this presentation, I'm referring to containers orchestrated using a service such as ECS or EKS. So now that we know what event-driven services are and why you should consider using containers to build them, let's actually talk about how you can build an event-driven service using serverless containers with ECS and Fargate. So generally, we see customers build event-driven applications on ECS using one or two application architectures. The first, and probably the most simple way, is to use a service such as EventBridge or step functions to process an event and use that to launch an ECS task. ECS is integrated natively with both of these services, so you can easily configure this action from either EventBridge or step functions. Any task launched in this manner is ephemeral. It will process the payload that was initially passed to it and then terminate. This is most useful for cron-style data processing jobs which you don't need to run at a very high frequency, but have compute considerations that might not be met by Lambda. An example of this is the data validation use case we discussed earlier. Let's assume that some raw data becomes available in an S3 bucket at some point of the day. When this happens, S3 generates an event which you can consume an event bridge to run an ECS task, which runs the validation and pre-processing that you need. Once this is completed, the ECS task publishes the validated data to S3 and exits. Because this workflow needs to run infrequently, you don't really need to keep a task running to poll for this event. The other common way customers build event-driven applications with ECS is in the form of long-running event processing services, which pull and process events from a message queue or stream. This is most useful for services where your event source has a steady and high volume flow of events. In this model, each task in the service is long running. That is, it runs continuously until it is terminated due to a scaling event, a deployment, or a process crash. Because this uses the ECS service primitive, you can use ECS service autoscaling to define your autoscaling policies and use ECS managed rolling deployments to safely roll out new applications versions. To build out such a key thing to keep in mind here, though, is that when you're building such an event driven service with ECS, you do need to implement the logic to pull and process the event from the event source within your container. A good example of an application which uses such an architecture is the transaction monitoring use case we discussed earlier. In this system, the payment processing app pushes a push notification to an SNS topic whenever it processes a transaction. This topic automatically pushes a message to an SQS queue whenever it receives a notification. To process this queue and validate this transaction, you can build an ECS service backed by Fargate or EC2, which pulls the SQS queue for messages and processes the transaction whenever it sees one. Because this is a payment processing system which likely sees fairly high volumes of notifications throughout the day with fairly low idle time, it makes sense to keep tasks running so that the application doesn't need to establish database connections or download data every time a transaction comes in. For most of the rest of this presentation, we'll be focusing on this particular architecture. We've discussed a few times so far about configuring autoscaling for your containerized event-driven services. As I mentioned earlier, autoscaling control is one of the key benefits of using containers for your event-driven service. ECS integrates with AWS application autoscaling to enable you to easily configure autoscaling for your ECS services. There are two key dimensions that you use to configure autoscaling for your ECS services. First is the metric that you want to scale your service on, and second is the policy itself that you want to use. The most critical thing to define here is the metric that you want your service to autoscale on. This could be one of three. By default, ECS provides CPU and memory utilization metrics for your containers running on ECS. You can define the target utilization metric for your application depending on whether it is CPU or memory intensive and use that for autoscaling. However, in addition to that, you can also use a variety of CloudWatch metrics which are emitted by both ECS as well as event sources such as SQS and Kinesis to autoscale your application. Common examples of metrics that customers use to autoscale their event-driven services include queue depth, the message rate in MSK, etc. Finally, you can also emit custom metrics to CloudWatch or Amazon Prometheus and use that for autoscaling your event-driven application. A common example of this that we've heard a number of customers who use SQS as their event source use is the queue backlog per task. The second dimension that I mentioned for ECS autoscaling is the policy itself. There are two key policy types that are supported in ECS. You can use a step scaling policy where you define the scaling step size and interval, or a target tracking policy where you simply define the target value for the metric that you want to scale on. We usually recommend using target tracking policy for most of your applications. One of the key reasons why customers choose ECS is for the simple yet powerful abstractions that we are continuously building for our customers. Two of the ways that we've been making it easier for customers to deploy applications without having to worry about infrastructure is with CDK and Copilot. In case you aren't familiar, CDK allows you to define infrastructure in your preferred programming language, while Copilot is an opinionated CLI for deploying containerized applications to ECS. Over the years, we have seen and heard a number of customers deploy event-driven applications in the form of long-running ECS services which process SQS queues. As a result, we have introduced patterns on Copilot as well as CDK, which allow you to deploy event-driven applications to ECS without having to worry about managing the underlying plumbing and infrastructure. When you use one of these, ECS manages setting up the queue, the task definition, setting up access for the application to the queue, and also builds in the best practice auto-scaling policies by default. One quick call out on this, you can only use Copilot with Fargate, while CDK allows you to use either EC2 or Fargate. For the demo today, I'll actually be using the worker service pattern on Copilot, which integrates with SQS to deploy an event processing service to ECS. All right, so with all of that out of the way, let me give a brief overview of the application that I'll be deploying to ECS with Copilot today. So now that we've discussed all about the what and why, let's look at the how. The application I'll be demoing today is an SQS queue processing service, which we implemented to add resiliency to an existing web application. The service is part of a larger two-tier web application which provides a front end for voting and tallies these results on a web UI. To make this application more resilient, we added functionality to make the front end publish a notification to an SNS topic whenever a vote is cast. We also set up an SQS queue which is subscribed to this topic. Finally, we deployed an ECS service on we will deploy an ECS service on Fargate that automatically pulls messages from this queue. What this enables is that in case the API service goes down, instead of a vote getting missed, this is consumed by the ECS event processing service, and which then publishes this data to the API service when the API service comes back up again. So with that overview out of the way, let's get started with the demo. So before we go ahead and deploy our event-driven application to ECS, let's take a quick look at the web application that I already deployed. So it's a pretty simple application built courtesy the Copilot team here at AWS. They clearly have a much better sense of humor than I do, but simple application. You can vote between cats and dogs, and that would get reflected on the results interface. So this is a simple interface which basically tallies and shows the votes cast for both cats and dogs. As you can see right now, we haven't deployed our service which processes the votes, and as a result, both cats and dogs are showing up as 0 right now. So let's go ahead and deploy our event processing service with Copilot. Now let's go ahead and deploy our event processing application to ECS Fargate with Copilot. Now, normally, before you get to this step, you need to install the Copilot CLI and configure your AWS credentials on your CLI. I've already done that. I'm using the Amazon Cloud9 editor here, which makes it super easy for me to build and deploy. So I've already git cloned the repository as well. As I said, I'll be linking all of the source code. So if you want to try out and deploy this application yourself using Copilot, you can do so. But I'm just going to go ahead and deploy the application. So I first go ahead and do a Copilot init, which initializes the Copilot environment. This is a worker service, as I said. And let's call it processor. Now, as soon as I complete this step, Copilot goes ahead and does a number of things automatically. First, it builds the container image from the repository, uploads this image to ECR, creates the ECS task definition as well as the service configuration for this worker service, adds the necessary IAM roles to access SQS from the task, and deploys the service to ECS Fargate. What's more, you can use the manifest for this worker service to easily configure autoscaling based on SQS metrics without needing to write any undifferentiated code. And all of this happens in just a matter of few commands, instead of needing to configure what would likely be tens of lines of CloudFormation. So, all right, the service is deployed now. Let's go ahead and check whether our application is accepting votes. I'll go ahead and cast a couple of votes for Crying Kitty, and let's refresh our results. We see the two results show up now. To test the resilience further, what I'm going to do now is kill a task on the API application. So I'll basically take down the API application, and the votes that we cast will still stay. So let me go ahead and kill the task. So I've stopped the task. I'm stopping the task. Let's go to the front end in the meanwhile. The front end is no longer working because the API is down. Let's go ahead and see if we can still cast votes though. I'm going to go ahead and cast 2 votes for the doggo. Now we'll go back and check if the API task is back up again. You can see the service is back to running. Let's go ahead and check whether our front end captured that vote. Well, there we have it. It did capture the 2 votes that were cast when the API service was down. I hope the demo provides an illustration of how you can easily build an event processing application using ECS and Fargate, especially with Copilot. All of the source code for this is available open source on GitHub, and I'll be linking to that in the resources at the end of this day. But before we close, I do want to take a moment to discuss some key considerations and a few takeaways that I'd like all of you to leave with today. So the first thing that really comes to my mind when I'm discussing event-driven applications with customers is the choice between streams or queues. This really depends on your application. So streams allow for more real-time information flow, while queues are more decoupled, allowing asynchronous communication, usually a little easier to set up. So depending upon what the flow of information and the event flow for your application looks like, you'd want to choose between one of the two. Another key thing to keep in mind is to be very sorry, I'll take that again. 3, 2, 1, go. Another really important thing to keep in mind is to be deliberate about when you're designing the actual event itself. One of the key benefits of event-driven applications is decoupling, and you want to make sure that your event captures all of the necessary information so that you're minimizing other dependencies for your application. This really enables your development teams to execute independently without becoming bottlenecks for one another. Thirdly, 3, 2, 1. Thirdly, when you're picking your compute layer for building an event-driven application with ECS, be careful about what your application's processing needs are. Say your application needs GPUs because of the volume of data, or it needs to use some libraries which are only supported with GPUs. GPUs are not supported currently with Fargate or other specialized infrastructure as well. Hence, for such use cases, you'd want to use ECS with EC2. However, for most other general purpose use cases, you should consider using Fargate because of all the abstractions that it provides in terms of infrastructure management. Finally, and in some ways most importantly, there is no silver bullet. You have to think through your application's needs and requirements when you're picking how you want to deploy your event-driven application. In many cases, it might be a robust choice to use AWS Lambda, while in some other cases, it might be better to use ECS Fargate. While there's some general guidance that we can offer, you should think through your application's latency requirements and dependencies when you're deploying, when you're choosing which compute layer to deploy your application on. Finally, I do want you all to leave with a few takeaways. While I said there's no silver bullet for picking your compute layer, as a general rule of thumb, you should consider using ECS for your event-driven applications where you have a stable, high-volume event source, or your application needs specialized compute, or it needs more than 15 minutes to process a single event. For most other event-driven applications, you should consider using AWS Lambda. Once you have decided to use ECS, consider using a mix of Fargate and Fargate Spot to optimize your compute costs. With Fargate, you only pay for the compute you need, and with Fargate Spot, you can get a significant discount for your fault-tolerant workloads. Consider looking into CDK and Copilot for an additional layer of simplicity. If your organization already uses infrastructure as code tooling, CDK might be a good fit for you, while Copilot provides a great way to get started with running and testing applications with ECS Fargate. Finally, to make sure that your application scales optimally for your requirements, you can use autoscaling with the appropriate metric, which can either be a default or a custom metric depending on your application. Those are the 4 things that I would want all of you to leave with today. With that, we're at a close. I'm linking a few helpful resources that you can look up later, and we'll be switching over to live Q&A. Thank you.